Today we will present the analytics components that we have, the backend and the front end. So here is a quick overview of today's presentation. We will start with a short introduction, followed by a look into the analytics components. So we will begin with the data collector, which is the backend component, and I will present two different approaches, the centralized and the decentralized approach. And then move on to the visualization dashboard, which serves as the front-end part. And finally, we will wrap up with some key conclusions. So in this slide, we can see the key roles and the responsibilities of the data collector in previous projects, like the 5G solutions and the 5G media hub. So the data collector gathers key performance indicators, KPIs, and key value indicators, KVIs, from various sources. So it acts as a middleware component. And when we are talking about various sources, we are talking about testbeds, experiments, network application, use cases, and enabling comparative analysis and performance improvement. Also, the data collector enables real-time tracking of experiment behavior, feeding dashboard with live performance insights, and using the data collector, we can collect data and persist this data in repositories for further analysis, for long-term analysis and configuration. Because the data collector gathers data from various sources, may use varying data collection and analysis methods in order to ensure a unified structure for consistent and comparable results. Also, in some cases, the collected data can trigger automated processes. The data collector, using pre-processing mechanisms, ensure personal data anonymization and data protection regulations. And also in these projects, we had some extra features. So by aggregating and processing experiment data, the data collector could help validate new technologies. So the first approach that we'll present is the centralized approach. The data collector is one of the most important backend components in the data analytics. It is responsible for collecting data, as I said, KPIs from testbeds, use cases, network applications, experiments, and any other source within each project. So the typical approach followed is decentralized, meaning that the data collector and other components or features are deployed on a dedicated server. As depicted in this slide, the data collector communicates with the analytics portal, through which users can trigger a new experiment or visualize KPIs from completed or real-time experiments. It also interacts with the testbed to retrieve or to receive network and application KPIs, with a database to persist the collected data for further analysis in the future, and also, depending on the project, the data collector in a centralized approach may also connect with the ELCM for user management, reporting, or any other project-specific feature. The centralized approach was followed in previous projects like 5G Solution, 5G Media Hub. In our case, in our project, we have the decentralized approach. Okay, so in the 6G path, we are following a decentralized approach, meaning that all the components are deployed on the testbed premises. Specifically, in our project, components such as ELCM, analytics portal, data collector, and InfluxDB are deployed locally. So when a user triggers an experiment through the ELCM, the data collector using the experiment ID can retrieve or receive data from the InfluxDB and forward these KPIs, this data, to the analytics portal for visualization purposes. Depending on the testbed or 5G network, application, and experiment, users can modify the appropriate configuration files, such as Kubernetes YAML file or Docker Compose files, to tailor the experiment and ensure the KPIs are sent to the portal for display. In my last slide regarding the data collector, I have attached a demo to present you how you can deploy your data collector locally. In this slide, we can see the GitLab repository of the 6G project, of the 6G Path project, and more specifically, the GitLab repository of the 6G Path data collector. As shown on the left side, the project is structured with separate folders for both Docker and Kubernetes configuration, allowing flexibility in how the data collector is deployed, either via containers or in a Kubernetes cluster. On the right side, you can see an example of the Docker Compose YAML file used for the production deployment of the data collector. It includes important environment variables such as InfluxDB, where is my mouse? The InfluxDB, host, port, token, okay, and measurements units. These are necessary for retrieving and forwarding KPIs to the analytics portal. All these files are included in the 6G Path GitLab, and more specifically in this URL. And how you can deploy the data collector on your premises? I have attached the demo file. It's around 3 minutes and 30 seconds. So this is the procedure in order to deploy locally the data collector. So by following these steps, you can deploy locally the data collector. We have added text instead of voice because we thought that it will be easier to deploy the data collector by using the text instead of pausing, going back, and hearing again the video. So I will push and upload this video, this demo, in the 60path cloud, and I will send an email that the demo is available in order to start deploying locally in your testbed the data collector. That's all from the data collector, and now we have to proceed with the front-end component.
Yes, thank you, Eftimi. Okay, then moving on to the visualization dashboard or the analytics portal. This is designed to integrate seamlessly with existing third-party experimentation systems from previous 5G triple P projects such as 5G Solutions and 5G Media Hub, as Eftimi has already mentioned. At the same time, it expands its capabilities to meet the specific requirements of 6G path. One of its core strengths is its ability to process and visualize both key performance indicators and key value indicators. And this allows users to track performance against set targets and baseline values, ensuring continuous improvement and optimization. Additionally, the platform is built to support multi-domain scenarios and closed-loop systems while incorporating robust security enhancements. It offers real-time data monitoring, advanced filtering options, and interactive visualizations, thereby empowering users with deeper insights and more efficient decision-making. Next slide, please. Turning to the 5G Solutions project and its relevance to 6G path. This image here represents the smart KPI visualization system from the 5G Solutions project, which is a foundational system upon which the 6G path visualization dashboard builds and extends, of course, its functionality. Now, the focal point of our interest is the web-based graphical environment in the red square. This environment serves as the interface where all processed data are visualized, analyzed, and interpreted by users. It transforms raw metrics into interactive dashboards, allowing users to track KPIs with real-time updates, advanced filtering, and insightful graphical representations. By building upon this system, the 6G path visualization dashboard takes the foundation established by 5G Solutions and improves it with extended capabilities, supporting more complex multi-domain scenarios, closed-loop automation, and enhanced security features for next generation networks. Next slide, please. Moving to the 5G Media Hub project and its relevance to 6G path, the 5G Media Hub experimenters portal main front-end components are the graphical user interface, the KPI visualization module, and the user management module. The portal graphical user interface provides access to all the experimentation engines and tools to the 5G Media Hub platform in order for 5G Media Hub users to design their experiments through the proper selection of experiments, NetApps, and service blueprints. Now, in the video here, we can first see the main two screens, login screens that are pushed by the UMM engine. Once the user enters valid credentials, she will be granted access with the access rights assigned to him or her. Of course, the user can navigate from the portal to other modules through the iframes based on his or her rights, user rights assigned from the UMM module. Going back to the Home tab in the UC description field, the user can also select NetApp's immersive media NetApp, which then gives the details of the NetApp and the option of selecting a NetApp execution from the drop-down list, or insert the NetApp execution ID manually via the Run Net option on the right. Then the time to run is shown with the option of stopping the NetApp execution. Here we can see 53, 52 seconds, etc. And the experiment has been stopped. Going back now to the drop-down list from the NetApp execution, if one option is selected, then the graphs with the relevant KPIs are shown. In a similar way, if one of the use cases is selected in the use case description and then a scenario description, many options are available, like start new experiment, schedule experiment, view experiments running, and of course, the option of selecting an experiment. Here, we can see the option of scheduling automatic experiment run with inputting, of course, the appropriate date and time along with some more options. Then the view pending and running experiments option shows the list with the experiments along with their details. Then the view resources status option lists the resources and whether they are busy or available. The Start New Experiment option again provides the option of inputting the experiment ID along with some more options, and pressing the Start Experiment option gives the time to run. Here we can see 54, 53, 51, etc. And of course, for the purposes of this dry run test demo video, the experiment was stopped. Now, going back to the Home tab of the portal and selecting another experiment, the graphs with metrics like the cloud run percentage, the GPU draw time, etc. are shown. And moving on with some features or options, if you like, of the Visualization Dashboard. It allows for data integration, customizable interface, interactive visualizations with various chart types like bar, line, pie, scatter plots, real-time data updates with live data feeds and auto-refresh capabilities to keep information current, filters and segmentation, performance metrics and KPIs, of course, which also offers the option of benchmarking against targets and historical data, data exporting in various formats, of course, PDF, Excel, CSV, or images, reporting tools, user management and permissions with role-based access control to manage who can view or edit specific data and dashboards, alerts and notifications, trends analysis and forecasting with tools for trend analysis to identify patterns over time, and predictive analytics and forecasting capabilities. And last but not least, mobile accessibility with a mobile-friendly design for access on smartphones and tablets. I guess this is it from us. Thank you for your attention.